challenging. Seeing the path itself can be really challenging. It's that old adage, like, if you know what the answer is, it's a little bit easier to get to the answer. And that's how big discoveries are made. Sometimes people have really strong feelings about what the answer should be, but they have to prove it, so they kind of meet in the middle. So you stare at this, you might try a few things, you might run up against something, you might try to create something, you might do proper math, but you might hit a wall. You hit another wall. Will you hit a lot of walls if you're actually trying creative solution methods? Absolutely. And then usually something will pop out. What was the substitution? I think all of you ended up figuring out this. Oh, I like that idea, trying to do it by parts, right? That's kind of cool. Does it work? No. Not so much, but he tried it, right? Here's the cool thing. If we're in trig identity land, what's the coolest trig identity? Yes, I'm asking you a subjective question and pretending like there's one answer. What's the coolest trig identity? Jerry?
Cosine theta plus sine theta equals 1.
Cosine squared, yep. Yeah, you're going to use this. It's like, oh, you need to unfreeze this. This is the bread and butter of what you're going to be doing for a bunch. That's what we're going to think in our minds as we do this. If you keep that in mind and you make this cool substitution, let's x equal, I don't know, sine squared theta. Do you want to do sine squared? Is that okay? Yeah. Could I do sine squared? Or just sine, not sine squared, sine. Is that okay? Yeah. Just watch, hold on, let's just see what happens, okay? The big key is like, why, right? Let's just see what happens. If you end up doing that, you end up with 1 over the square root of 1 minus sine squared theta. You still have dx in there. What is 1 minus sine squared? Cosine. So you have 1 over the square root of cosine squared theta. But what, oh wait, what's dx going to be? Cosine theta what? Come on, chain rule. Cosine theta what? Not chain rule, but you just had, there you go. So this is cosine theta d theta. What's the square root of cosine? Squared. Oh, it's just cosine theta over cosine theta d theta. So what is that? The integral of? So it's theta plus c. What is theta though? What is theta? Sine what? No. Sine what? Sine inverse of x. Do you agree? So we now know our final answer is sine inverse of x plus c. You also just figured out, what did you just do? You just found that the derivative of sine inverse theta is that. Have you seen this thing before? Yeah. That is the derivative of the inverse sine function. And you just proved it. Okay?
It did work.
Oh, did it work?
Yeah.
Oh, cool. It worked because you just recognized it and used that, okay? So, sure, there's very, like, what does it mean to prove something, right? Like, you prove something with this foundation, right? But then, what do you, theoretically, it's all tautological. Here's what I mean. Like, you have to come up with a base set. Like, what does it mean to prove something? You keep on breaking it down into its further, like, composite elements. In that, you prove the answer, but you kind of used it to prove it, right? Do you see what's going on there? Like, if you know that b prime is 1 over 1 minus x squared, you could jump there, but that's what you're proving in the first place, okay?
We're not proving it.
Yeah, this proves it. Yeah. That finds it, using the same fact. Yes?
Sorry, just to back up. So are we just supposed to know that sine of the inverse sine of x equals x?
Because this statement right here is the same thing as writing sine inverse of x equals theta. That's the same statement. That's what it means. If x equals sine theta, sine inverse of x equals theta. That's the definition of sine inverse, everybody. That's the definition right there. Not going to dwell on it. That is the definition of sine inverse. Okay, let's just talk about this one briefly. What's the only difference here? What number 我们不喜欢什么记？4。为什么我们不喜欢记1、2、3、4？ Why don't we like 4 here? Why? It's not what? We want it to be 1, right? Yeah. 我的中文好，我的中文好，对。谢谢。So we want to get rid of it. It's just going to change. It's just going to change our substitution. Sine will still be involved. Anybody want to guess what the substitution's going to be? Anybody want to guess what the substitution's going to be? We want x to be, anybody want to guess? Just guess. How about 2 sine theta? What happens if x is 2 sine theta when we do the substitution? What happens? 4 minus what? 4 sine squared theta. Oh, and then you still get what? 2 cosine theta d theta, right? Why is it nice? Where did I get what?
Where did you get the 2 cosine?
The derivative. dx is 2 cosine theta d theta. I'm going straight to theta. I didn't want to keep it in x. Why is that cool? What can we pull out? What can we pull out? And what does it become? A 2, right? So what happens? What happens here? So you end up with 2 cosine theta d theta in the numerator, right? But then you end up with 2 times the square root of what? 1 minus sine squared theta. Is this correct? Anything cancel there? Oh, is it really nice? What did you say? Everything? That's gone, right? And what's gone right here? Oh, it's gone, right? So what does this actually equal? Theta plus c. Congratulations. The only difference here is, what is theta equal to this time? Sine inverse of what? X over 2. You have to divide first and then do the inverse. You have to divide by 2, then do inverse sine. So here, what do we have? Sine inverse of what? This step right here, massaging it to get to something you can work with, will be easier if you've burned into your retinas the really important things. Derivatives of inverse trig functions, derivatives of inverse trig functions. If you don't automatically recognize those, gonna be painful, kids. Because the key step here is the algebra very hard on this? Not so much. If you have an idea of where to go. If you don't have an idea of where to go, what happens? Oh, sad. So sad. Let's do another one. Get up, find this out. You end up with a nice shape that looks like this. That's a terrible ellipse. But what is this going to be? 3. What's this going to be? This is what I need you to do. Come to terms with that. Have you come to terms with that right there? Are you okay with that? Yes. The first quadrant, right? And you can use this piece right there. What is that piece? Tell me what the function is for that piece. Write it down. You have 5 seconds. Go. 5. I would imagine that you ended up with something maybe that looked like this. 4 times the integral of what? The square root of what? 9 minus 4x squared dx. Did you get to that? Yes. That's pretty cool. 4x squared. Okay. So, and what do you, it's from 0 to what? 4 quadrants. 4 quadrants, everybody. 0 to what? Why 3 over 2? Doing the x values, right. I'm seeing what I like what I see so far. Alex, everybody turn around for a sec. We're all talking about it facing forward. It's to 3 over 2. Why? Because it's integrating with respect to x, not y. We could do it with respect to y. It doesn't change much, actually, but we like looking up and down, right? We look up and... Okay. Is that a relatively simple thing to write? How confident are you with understanding where we are right now? 5 is you got it. 0 is you have no idea what we're doing. 5, we're good. 4, 5, 3, you're somewhere in here. Do you understand the expression that's on the board? Could we do 2 times negative 3 over 2 to positive? Sure. We want to do it. We like plugging in 0 into things. This is absolutely a type of question you could get on the AP exam. They could say, write, but do not evaluate. Why is it kind of a nice thing that they say don't evaluate right now, at least? I'm kind of presaging this right now. This is nice to write, but what? 可是 this is a little bit difficult. Nan is difficult, little bit, okay? Here's the thing. We love rearranging these things to use trig functions, right? Can you tell me as clearly as you can what structural element in here makes it a little bit annoying? Which structural element in here makes it a little bit annoying? Yeah, Ian.
The 4 in front of the x squared.
It's not the 4. If it was just the 4, you'd be okay. The 9. You don't like the 9, do you? Do you like the 9? You don't like. You just don't like. You want it to be the same, right? But don't be too biased. Don't be too biased, right? Don't be too biased. Do you see something minus something squared?
Yeah.
You see something minus something squared, but you want it to be not something. What do you want it to be first? We're not putting another x in there. No more x's. No, we're not doing that yet. No. We love it to be 4. Why would we want it to be 4? And create a what? What do we want to be leading? We love it to be what? Not 9. We love it to be a what? A 1. We'd love it to be a 1, right? Because what was that trig function we loved? What was that trig identity we loved? Cosine squared plus sine squared is equal to 1. 1 minus sine squared. We could do a trig substitution, get something. Oh, it's a square root of something squared? So do you kind of see what we're going to try to do here? We want to make it sine or cosine squared so that the square root does what? Disappears. Someone else start writing. Try to figure out what you substitute. This is what I want you to try to figure out right now. Come up with a guess as to what you substitute. You have 1 minute to try to come up with a guess for what you're substituting in for x. 1 minute. Tell me, what do you think x should be in this case? Someone raise their hand and tell me what they think x should be. Ian, what do you think x should be?
9 over 4 sine of x.
9 over 4 sine of x? You think it should be 9 over 4 sine of theta?
Yeah. Sine squared.
X should be that?
No.
What should x be? Be very careful. I understand you did that correctly, but I want the answer. If I ask you, what should x be? X should not be that. What should x be? Yes.
3/2 sine theta.
Yes. 3/2 sine theta. Because when you do the substitution, what do you end up with? 9 minus 4 times 3 over 2 sine theta squared. We're still in dx now, but what happens on the inside here? 3 over 2 squared is what? 9 over 4. And what do you end up with? 9 minus 9 sine squared theta dx. What's the problem with that right there? What can we take care of quickly? What can we pull out? It turns into a 3 by taking out a 9. So what do we end up with? 3 integral 1 minus sine squared theta dx. What's the problem still?
There's no 1 over.
No, we're not done yet. We're far from done. We need d theta. So we go up here. What is dx equal to? 3. Yeah. Theta what? D theta. So instead of dx, what do we have? 3 times, the square root of cosine squared theta. And what is this? 3 over 2 cosine what? Cosine theta d theta. Is that correct? So what do we have here? 9 over 2 times cosine squared theta d theta. That's where we are right now. But we're not done.
It's just cosine.
No, it's not. Because when we do
you're
dx,
multiplying it. Yeah,
we're multiplying it, right?
Yep.
If it was, then our life would be so much simpler, Ian. It's not simple. We're in BC. It's not simple anymore. What have I not written in very deliberately? What have I not written in?
The limit definite integral.
The what? The limits of integration. Yeah, we haven't made it a definite integral. The thing is, unless we're going to evaluate it now, which we're not, I don't want to write them in yet. I want to go all the way back. I want to go all the way back. Meaning, I want to actually integrate it and then substitute at the end. Okay? I want to integrate it and substitute at the end in terms of x. Or theta, it depends, because we're not done yet. Effectively, I don't want to use our calculator, so I want to get to something we're not going to use our calculators for. Have we looked at this before? Does this look familiar? This should look familiar, right? Again, is this nice to write? Is it nice to solve? Not bad. What method do you think you have to use for this one? Parts. Parts. You might have memorized it. I know you might have memorized it. Use parts for me and integrate that for me. Tell me what that is. Go. Get rid of that integral. I don't want that integral. You end up with, end up with 18 times cosine theta, sine theta over 2, or plus theta, sorry. Like this. You end up with that.
It's frozen.
Oh, it's frozen. Thank you. So you end up with this. Here's the thing. You now have to figure out what you're going from and to. What did x equal, everybody? What was your original substitution? No, the original substitution was what, 3 over 2 sine theta, right? So 2/3 x is equal to what? Sine theta. So what does theta equal?
Inverse
Sine of 2/3 x. So we're going from 0 and 3 over 2. Those are the two values, right? So when x is 0, you have theta equals sine inverse of 0. What is that? The sine of what is 0? Oh, that is 0. So that's when x is equal to 0. What about theta when x is equal to 3 over 2? That's sine inverse of what? 3 over 2 times 2 over 3 is sine inverse of 1. The sine of what is 1? The sine of what is 1? Pi over 2.
Why is it 3 over 2 times 2 over 3?
Because we had
X
theta is equal to sine inverse of 2 over 3, right? So you're plugging in 3 over 2, and 2 over 3 is already there. So what are we evaluating this from right here? From 0 to what? Pi over 2. What is sine of pi over 2?
1.
What's cosine of pi over 2?
0.
Oh, so does something happen here? So you have 9 cosine theta, sine theta, plus theta from 0 to pi over 2, right?
Yeah.
So what is that? 9 times cosine pi over 2 sine of pi over 2 plus pi over 2 minus 0, right?
There's 9 pi.
So what do you end up with? 9 times what? Pi over 2. No calculator necessary. We just calculated the exact area of that arc, the ellipse. Now here's the thing, everybody. Here's the thing. When you end up with super clean answers like that, go back and look at what you started with to see if that infers a formula. What's the area of a circle? Pi r squared. Is there one radius in this case? How many radiuses are there? 2. R1 is equal to 3 over 2. What's R2 equal to? 3. Anybody want to guess what the formula is for the area of an ellipse? Pi R1 R2. Oh wait, did that work here? 3 over 2 times 3. Area is equal to 9 over 2 pi. Is that the same exact thing? What it is, but here's the thing. No, listen. That is easier, but what you've done, can I just give you the payoff here? What you've done, could you generalize this if you wanted to? Yes, instead of 4 and 1 as the coefficients, and 9 as the c value, you can make it A, B, and C. And what do you end up with? The formula for ellipses, right? What is a circle? A circle is just a subset of an ellipse, right? Where R1 is equal to R2. You've done something that's actually really hard to do, which is the following. You've done this for your entire math, well, not your entire math career, but most of it. What's the area of a circle? Pi r squared. Up until this moment, have you been able to prove that? No. Could you prove it now using this method? Yeah, you could use this method to prove that the area of a circle is pi r squared. You were first given that probably in Algebra 1 or Algebra 2, or when? Algebra 1 probably, right? Maybe even earlier, right? Here's the thing. It's useful, it's pertinent, it's important, but can you prove it in Algebra 1? No. You need calculus to do it. Are there tons of things we're doing in calculus right now that you only prove in college math? Yeah. There's tons of things we've taken for granted that you will later prove. For example, have you ever used the chain rule before? Yeah. Prove for me why the chain rule works. No, you can't do that yet, right? Issues surrounding continuity, like what is continuous? Oh, get ready. Epsilon delta proofs. You're gonna love it. Okay. One more thing I want you to look at before we. So, what do we want it to make it look like? Maybe x what? Let's just. What is x minus 1 squared equal to? That's x squared what? Minus 2x what? Plus 1. Let's factor out a negative. What do you get? Negative x squared what? Plus 2x. Do you agree with? Okay, that's there, right? Okay. Oh, man, does this help us at all? Okay, so then that's almost what we have there, right? We have, what do we have here? What do we have? We have 2x minus x squared. That's, where is that? That's right.
And then minus 1.
So, what do we need to do? What should we do, everybody? What do you think we should do? Should we add 1 or subtract 1 or do both? Oh, we have. Why do we have to do both, Nam?
Because they cancel out in the end.
Yeah. So what do we change this into? Well, if we change this into 2x minus x squared plus 1 minus 1, have we changed anything?
No.
We haven't changed anything, right? I don't think so. But what do we now have? Could we factor out a negative now?
Yes.
Sure. What do we end up with? Negative. What is it? Oh, wait, hold on. What do we want here? We have, oh no, we can just reorder it, right? What do we have here? Negative x squared plus 2x minus 1 plus 1. All I've done is reorder the plus and the minus. But what does this equal right here? What can we do with this?
Negative x minus 1.
What is it?
Negative x minus 1 squared.
Oh, negative x minus 1 squared? So what do we have here? Negative x minus 1 squared plus 1 dx. Are you okay with this? Are you okay with that? Okay, so we don't really like having the negatives forward, so now we have 1 over the square root of 1 minus x minus 1 squared dx. Is that 1 minus something squared?
Yeah.
So what can we substitute in there? W equals what? X minus 1. So what does dw equal? Dx. So what do we end up with? 3 integral of 1 over what? 1 minus w squared dw. What is the integral of 1 over 1 minus w squared? So that is sine inverse of W plus C. But what is W equal to?
I thought we were supposed to be proving that.
Not, we just did. Now we don't have to. No, you don't have to anymore. I'm just saying we've proven what we can do. You are allowed to use the derivative of inverse trig functions unless explicitly told you have to prove it. So what do we have here? Oh, so here's the thing. Overall, this ain't bad, but what's the magical thing you have to recognize? Right there. The magical thing you have to recognize is algebra. Not easy to see because how many different things can you do without anything? Pretty much anything. A lot. Okay, take out a